Hey guys, lesson 3.1, decimals between integers. Please take a moment to complete the following warm-up. You should possibly consider drawing the number lines into your notes and making sure that you can correctly locate 26 and 172 thousandths on each of the number lines. Alright, great. Hopefully you've got your answers. We're going to refer to this warm-up a little bit later in the lesson, so if you did not get a chance to answer this question, you should make sure to do that at this point. In our warm-up today, we need to consider the fact that our decimal system is infinite. As you guys know, there's an infinite amount of numbers. We can get really big, and even bigger than the number that you see here, or we can get really small, even smaller than the numbers that you see here. This is really neat for us because our decimal system is infinite, so we can also find numbers that are in between two numbers. Even when it seems like two numbers are consecutive or right in a row, we can always find something in between by using the next decimal place to the right. For example, when we were in elementary school, it was 1, 2, 3. There was nothing in between those two. But then we heard about 2.5, 2.6. We found the tenths place, so we were able to find some numbers in between. At some point in time, it might seem like 3 and 67 hundredths is right next to 3 and 68 hundredths, but not if we consider the thousandths place. Then we've really got 3 and 670 thousandths, 3 and 680 thousandths. So we've got 3 and 671 thousandths, 3 and 672 thousandths, 3 and 673 thousandths, etc. in between. Every time we add a decimal place to the right, we can always find a number in between. Try it. Find any number between 5 and 81 hundredths and 5 and 82 hundredths. When we're taking a look at this sort of thing, we consider intervals and tick marks. Tick marks are the lines that divide up the number line. They usually represent a specific value for us. The intervals are the spaces between the tick marks. They usually represent us an exact value. They help us determine which number is on each tick mark. These numerical values. When we want to graph numbers or to read numbers on a number line, it's really important for us to decide which tick marks it should be in between. This will also help us to identify the value and use the next decimal place to decide exactly where between the two. An example from the warm-up. We were asked to graph the number 26 and 172 thousandths on the following number line. This number line has an interval or a scale of 100 because we're counting by 100s. We've got 0, 100, 200, 300, etc. If we take a look, since there's a 0 in the hundreds place, this is somewhere between 0 and 100. So we know it's somewhere between 0 and 100. The 2 in the tens place tells us that it's closer to 0 than it is to 100. This is kind of like trying to find Edina on a map of North America. The scale on our map here is pretty large. 1 inch would stand for a pretty great distance. Just like the scale on our number line is fairly large. Each space stands for 100. Just like we can zoom in on a map, we can zoom in on a number line. For example, I might change the interval on my number line so I'm counting by tens. This is like zooming in. Maybe I'm looking just at the United States then. Here, this space represents 500 miles. Taking a look, we know with the 2 in the tens place that this is somewhere between 20 and 30. Considering the next decimal place over to the right, the 6 tells me it's a little bit closer to 30 than it is to 20. We can zoom in even further, just like I can zoom my map into just isolate Minnesota. I can zoom my number line in and count by ones. With the 6 in the ones place, I know this is between 26 and 27. The next decimal place over the 1 identifies that it's pretty close to 26. We can zoom in even further and look just at the Twin Cities. Each time we zoom in, we have a better idea of where the number is. Where the city is. Same thing on the number line. We know that this is somewhere between 26.1 and 26.2. The 7 that we've got here in the the hundredths place shows us that this is a little bit closer to 26.2. We can use this idea to help us put decimals in order as well. We always want to line up the decimals at the decimal point in order to put them in order. There's two methods here. You're going to actually see an example of both of these methods, and then you can decide which one you'd like to write in your notes. So let's check them out. Method number 1 is where we compare the largest place value first, move to the right until one is larger. We always want to consider invisible zeros. So I think about the ones place. That's the largest place value in this one. They're all the same. Doesn't tell me which one's bigger or smaller. Looking to the next space to the right, we see the tenths place. They're all the same. Doesn't identify one number as being larger or smaller. When I look at the hundredths place at this point, the 2 is the smallest of all the numbers, so I can identify this as the center number as the smallest of the 3 values I have. Looking next to the thousandths place, our invisible 0 right here tells me that 2.06 is the next smallest number, with 2.062 being the largest. Method number 2 is to add zeros so each number has the same name, the same place value. Remember, we name a number based on its place value. If I follow the same process, I make each of these numbers end in the 10,000ths place. 2 and blank 10,000ths. If I have 2 and 620 10,000ths, 2 and 262 10,000ths, 2 and 600 10,000ths, 262 is less than 600, is less than 620. Therefore, 2.20262 is smaller than 2.06, is smaller than 2.062. So choose the method that you're going to plan to use and write it in your notes. Complete the following example by following that method. Write the 3 following numbers in order from greatest to least. Method number 1. Method number 2. Our last step is here to compare decimals, find out which is the largest. We want to be very careful with negative numbers. It often helps to think of temperature. If it seems colder, it is a smaller number. Closer to 0 in the negatives means it is a bigger number, and further to the left on the number line means a smaller number.